Hi, this is the first part in a series of videos about Lewis structures, which can also be called Lewis dot diagrams. The Lewis structures are used to help to understand bonding in molecules. What we use is we use the symbol of the element to represent the core electrons, and then we're going to use dots to represent valence electrons. If we want to represent a bond, we can use lines as is represented in these diagrams, or we can use a pair of dots. Here is the same example for nitrogen, where we're using dots instead. So, each bond has 2 electrons. We can represent that as a pair of dots or just a simple line. Before we tackle the Lewis structure for molecules, let's take a look at how you do Lewis structures for atoms to get warmed up. Now here's an example of the Lewis structure for fluorine. And we're going to compare this with its electron configuration, which is 1s2, 2s2, 2p5. As I mentioned before, the dots are representing valence electrons. And for this example, 2s2, 2p5 are the valence electrons. The valence electrons will always be in the s and p sublevels. So the format that we have in general is going to look like this. You put the element in the center, and then the 4 spots around are going to represent the different orbitals that are in the valence shell. So I have 3 of them for the 3p orbitals, and I have the 1s orbital. Now it doesn't matter where you put these, and so you can move the s's and the p's around, and that's okay. But this also goes to show you why the electrons are going to always come in pairs. Let's try another example, and we'll see how that works. Let's try sodium as an example. The electron configuration is 1s2, 2s2, 2p6, 3s1. So for the valence shell, all we have is just the 1 electron at 3s1. Now there's an easier way to figure out how many valence electrons an element has rather than coming up with the electron configuration every single time. All we have to do is just look at the group number that the element is in on the periodic table. So for this example, then, we just have the 1 valence electron, and I'll put it here. Let's use nitrogen as our last example. So nitrogen is in group 5, and we're going to need 5 valence electrons. So the first 2 electrons I'm going to put paired up because they would go into an s orbital, and then after that I have to follow Hund's rule, and I'm going to spread the electrons out. As you can see, this matches what we know about nitrogen from its orbital diagram. Let's review what we've learned. Dots are going to represent valence electrons. The number of valence electrons equals the group number. The 4 areas around an element's symbol represent the 4 orbitals in the outer s and p sublevels. Since each area represents an orbital, don't put more than 2 electrons in each area. Lastly, make sure to obey Hund's rule. Now this is only going to apply for working with Lewis dot diagrams for elements, and we won't have to worry about Hund's rule when we work with the molecules.